Well, hello to all my physics pals. Paul Lake here with another physics problem solved. This is the channel where I solve the physics homework problems provided to me by my tutoring clients. Take a look at the video description for a way to get in contact with me if you need a private physics tutor. My rates are reasonable and I'm really pretty good at this. And if you find this video helpful, please like, share, and subscribe. And let's get to today's problem. It is a kind of a beginning kinematics problem for a calculus-based physics class. I'm really targeting this particular video towards AP Physics C. And, or if you're in a calculus-based freshman physics class at the collegiate level, you'll find this to be helpful. We're going to talk about velocity acceleration given a position function. So you need to know what position means, what velocity means, what acceleration means, and you need to be able to take a derivative using the power rule. And I'm going to go through this with you, but if you looked in the video description, there's some links to a lecture on how to take derivatives for physics students. It's kind of a crash course on how to just take the basic derivatives you need. A lot of students take a calculus-based physics class concurrently with their first calculus class, so that's kind of why I've done that. So, but let's read today's problem. We have a particle, and it moves along the x-axis according to the equation x equals 2 plus 3t minus 1t squared, where x is in meters and t is in seconds. And it is in, oh, I meant, and t is in seconds. I'll have to fix that. But t is in seconds. At t equals 3 seconds, so we want to know at 3 seconds, we want to find the position of the particle, its velocity, and its acceleration. Hey, why don't you pause the video right now and try to work this problem yourself? Restart the problem if you get stuck, or you just want to check your work with mine. Hey, scroll around, have fun. And all right, let's get started. What is given? I always write down what's given. Well, we have this position as a function of time is equal to 2 meters. Now, one thing I don't like about the way this problem is set up is that it doesn't use units. This is almost like a pure math problem. Don't worry. Coming up soon in your physics assignments and so on, you'll be expected to put in units, and it will make more sense when you do that. But for right now, we're just going to do it this way. Okay. So this is my position function. And what are we trying to find? Oh, well, we want to know what is the position when t equals 3 seconds. So I put x, that's position at 3 seconds. We want to know what the velocity is at 3 seconds. And we want to know what the acceleration is at 3 seconds. And this is for part A, this is for part B, and this is for part C. Okay. And let's solve it. Okay, let's do part A. We want, what is the position when time is equal to 3 seconds? So here we have an expression for our position as a function of time. And all we have to do, if we want to know what is that position when time equals 3 seconds, is just wherever we see the variable t for time, we just plug in 3 seconds. So we're going to do that. X at 3 seconds is equal to 2.00. So we're always going to add 2 no matter what. Plus 3.00. Now this would be 3.00 meters per second because we're going to multiply that by 3 seconds to get meters. But again, we're leaving units off on this problem. Bad. I don't like doing that. And then this is minus 1.00 times 3 seconds squared. And now we just need to do the arithmetic. This is 2.00 plus 9.00 minus, well, this is 9 times 1 It's 9.00. And these are all in meters. Meters. And 9 minus 9 is 0, and all we got left is 2. So when t is equal to 3 seconds, our position on the x-axis is at 2 meters. That's what that means. Okay? Hope that's clear. If it's not clear, if you have a question, put it in the comments, or if you think I made a mistake, put it in the comments. I respond to every comment. My channel is not huge. I can do that. All right. B. Maybe my channel will get huge someday, but I don't know. I'm just doing this for fun. I'm a retired physics teacher, and I like teaching. So this lets me do it. All right. So let's do velocity. Now, before I can get velocity at 3 seconds, I need to know what the velocity is as a function of time. Now, here's one thing that you should know. Velocity is the time derivative of position. That is, if I take d dt of the position function, well, we'll just call that x of t, that's my velocity. And you can kind of think of this as a delta x over delta t, right? How much I change my position as time changes, but we let those delta t's shrink to 0. They go to 0. They approach 0. They never reach 0 because you can't divide by 0, but they get really close. All right, infinitesimals they're called. All right, so all we need to do is operate the derivative on the function. All right, let's just go ahead and do that. So this is 2.00 plus 3.00 times time minus 1.00 times time squared. Now I'm going to assume you're pretty new to calculus, all right? And so whenever you have this as a polynomial in terms of t or to time, and so when you have a polynomial and you want to take the derivative of it, you use the power rule. And the power rule says this: the derivative with respect to time of some function where you have a constant, I'll just call it capital A, times t, because we're taking the derivative with respect to t, to the n power. If we take the derivative of this, and a is just any constant, t is the derivative, and then n is some exponent, well, the derivative turns out, well, you keep the a, and then you bring this n down and you multiply by this n, whatever it was, and then you subtract 1 from this power of time. Now, here's why you subtract 1 from it, because look what we're doing. We're dividing by time. So it's like, this is like t to the 1. So when you're dividing by t to the 1, right, you subtract 1 from it. That's kind of what's going on. I think mathematicians might cringe a little bit at that explanation, but that's kind of what, that's really is kind of what's going on. All right, so now we have to take this derivative. Now, the nice thing about polynomials is that one thing you think about a polynomial like this, is that it's this function added to this function added to this function. So this is a sum of 3 different little functions. So I could just take the derivative of each little function and then add those together to get my overall derivative. The derivative of the sum is equal to the sum of the derivatives. You may have heard that before. But anyway, so let's take a look at taking the derivative of the first part. How does 2 change with time? Well, it doesn't change with time. It's a constant, right? I mean, if I were to graph this, let's just draw a little graph right here. If I graph, x as a function of time, and I just ignore the rest of it, I just ignore and say x as a function is just 2. Well, that's just a horizontal line. Here's 1, here's 2. That's just a horizontal line. What's the slope of a horizontal line? 0. It has 0 slope. It also works with the power rule, because you can kind of think of this as being 2.00 times t to the 0 power, right? Because anything to the 0 power is 1. So this is like 2 times 1 is 1. So now if I apply the power rule to this, I get the 2.00. But then I bring down this 0, and then you have t to the 0 minus 1. That's t to the negative 1. But it doesn't matter because you're multiplying by 0. So that means the derivative is 0. It makes sense if you graph it, and it makes sense if you go through the mathematics of it. All right. Hopefully you understand it. So this is just going to be 0 plus, now this is like 3.00 times t. That's like t to the 1 power. So I'm going to keep this 3 using the power rule. See, this 3 is my a. So that's going to be 3.00. And then I bring the 1 down, times 1. And then I have t to the 1 minus 1. Okay. Well, what is that? What is t to the 1 minus 1? That's t to the 0 power. Well, what is t to the 0 power? Anything to the 0 power is defined to be 1. So this is 3 times 1 times 1. So it'll be equal to 3. Now let's do this next part, minus, and then now my a is 1. And then my n, I'm going to bring this down because the power rule to bring this n down. So that's going to be 2. And then this is going to be t to, because I've divided by t here, this is going to be t to the 2 minus 1, which is t to, well, 2 minus 1. I'll just go ahead and put that in there. And now we can express my answer. This is 3, right? Minus, now what is 1 times 2 times t to the 1 power? Well, 1 times 2 is 2, and t to the 1 power is just t. So now this is my function for velocity as a function of time. But I don't want the velocity function as a function of time. I want the velocity at t equals 3. So all I have to do is plug in 3 for t. So v at 3 is going to be equal to 3.00 minus 2.00 times 3. Well, 2 times 3 is 6. 3 minus 6 is negative 3. So v at 3 is equal to negative 3.00. And what units? Well, it's going to be meters per second. And that is my answer for part B. Hey, is this helpful? If this is helpful, do me a favor, like the video. And if you're a physics student, subscribe to the channel. Show the channel to your teacher. If you're a teacher, feel free to use my stuff as much as you want. And I have several teachers that use my videos, and it's just like it's an honor. I love it. It makes me feel like I'm still doing some good in this world. All right. And who doesn't need that? Okay, now we're going to find the acceleration. Well, the acceleration as a function of time, well, that's the time derivative, the slope of my velocity equation. It's the rate of change of velocity. How fast is your velocity changing? At what rate? How many meters per second do I change every second? That's kind of what that means. Okay, and so, well, that means we're going to take the time derivative of velocity as a function of time. Well, I have that right here. So I'm going to say that's the time derivative of 3.00 minus 2.00 times t, and this is t to the 1 power. Go ahead and put that in there if that makes you feel okay. And then now we can figure out what the acceleration function is by taking the derivative. And again, just like last time, that when you take the derivative of a constant by definition is not changing with time. So its derivative is 0. The rate at which it changes with time is 0. So this is going to be 0 minus, now what do we do here? Well, we take that using the power rule, 2.00, that's kind of my constant here, and then bring this exponent down, and then this is going to be 1 minus 1. And just like we did before, you have 2 times, or negative 2 times 1. And what is t to the 0 power? That's 1 as well. So it's 2 times 1 is 2, but it's got a negative in front of it, so it's going to be negative 2.00. And the units are, well, we're changing, this is meters per second, right? Every second. So you can write this as meters per second every second. It changes by negative 2 meters per second every second. That's what acceleration means, right? But we don't usually write the units that way. And by the way, notice that the acceleration doesn't depend on time. So the acceleration, this is the acceleration. So the acceleration at 3 seconds or at any time t, the acceleration is a constant. Negative 2.00 meters per second squared. And there you go. Here's our answer to all 3 problems. And, okay. Hey, if you haven't already, give it a like. And thank you for watching. And until the next video, may the net force be with you always. That is all.